Hi there. So we're now going to take a look at doing the bit that I'm sure a lot of you have been waiting for, the fully continuous 5-axis surface machining. Specifically, we're going to be looking at these surfaces going all the way around the upper section here. So, first things first, as always, we define a new group because we want to keep everything tidy, which we are going to call surfacing. And we are going to define a 5D surfacing operation. So we are going to want to, firstly, we are going to need to turn on tool center point management, okay, which is vital since we're going to be making some transitions around the coordinate system with this, and it's going to move with us because it's obviously interpolating multiple rotary axes as well as linear axes. We are going to stick with the 6mm spherical tool because for the sake of this it's ideal, and we are going to take let's go with this surface first since it's directly in front of us and rather easy to get to. Go with that for now. So that's going to be our machining surface, and we are going to go from the first curve here to the second curve here. And let's take a look at some of the strategy settings. So initially it will come up with parallel to vertical face, which is not really what we want. Ideally we'd like to morph between two curves because that's, it's fairly useful. We are also going to change the tool orientation from fixed to normal to surface because this is going to be notably more useful in this regard. Because this means that instead of just pointing down and really not making much use of the 5-axis capabilities of this machine, the tool will always be perpendicular to the immediate point of the surface that it's touching. So let's generate the toolpath for now and see what comes up. And to be honest with you, that's already looking pretty good as far as I'm concerned. So I'm thinking that we can probably simulate this. I'm going to modify the links and lead settings first though, because that is, yeah. Doing safe surface motions on a plane in a 5-axis operation is, it's a good way of getting yourself tied up a little bit because obviously the plane moves with the part as far as the tooling is concerned, so it can sometimes lead to some very unwanted results. So the best thing to do is to change the safe surface to a sphere, obviously not one that big, and we can define the origin of that sphere to a custom point as well as the size of the sphere. So I'm going to shrink this sphere down. Let's that's a much more rational sort of size. So as you can see, I basically scrolled the number down, holding down Control to go down in increments of 10mm. This also meant that I could get a much more consistent view of what the numerical change was going to mean in terms of the part itself. The last thing we need to do is ideally we want to move this down in Z a little bit so it's a little bit closer to the, sorry, let's just straighten this up, a little bit closer to actually just maintaining the envelope of the part itself. So we're going to do the same with the scrolling and holding down Control, and that looks pretty rational. That gives us a nice range of safe area whilst also inflating that sphere a little bit, even though it is still nominally defined as being -150 from the part. So with that, I think we can probably take a look at regenerating and then simulating that toolpath. I'm certainly not seeing anything unexpected or unwanted there, which is good. So yeah, let's get that up to the current operation, and we are going to run this now. And as we can see, there is it's a pretty clean and consistent result there. We'll run verify compare just to check, and there is nothing unexpected there. That's rather good. I'm happy with that. So I think the next thing that we need to do now really is we're going to need to take a look at this chunk here. So let's do that. So again, for the sake of expedience, I am just going to duplicate this operation because, you know, don't work hard, work smart. And we're just going to change the job assignment details a little bit. So let's delete all of these settings. We're going to set this as our first curve and this as our second curve, along with grabbing all of the relevant surfaces. Now it's worth noting there is obviously a gap in the middle here which we need to be aware of. So we're going to have to play around with some other settings as well. But if we were to generate the toolpath for now, we would see that there's still that fairly sensible transition around the sphere, and there are no unexpected or untoward crashes insofar as I can see. Yeah, but we can see there's a bit of a weird jump and transition over here, which is not really ideal. So if we were to have a look through the strategy tab, we can actually see there's a gap capping option here. Now this is very handy for us because it means we can basically tell it, don't worry about jumping away from this section here, literally just treat it as if there's a surface and keep machining, but at a level consistent with the actual surface we are machining. However, we do need to tell it how big of a gap we want it to be okay with jumping over. And of course, we can't guarantee that the line is going to be perfectly straight, because if so, we'd know that was about 30 millimeters, I think, off the top of my head. So I'm actually going to suggest that we bump the gap capping up to about 50 millimeters for now. Seems a little extreme, but it should pretty much cover us in case of any strange angles transitioning across as well. And we're going to regenerate that toolpath now. And as we can see, there are some slightly longer lines and angles there that sweep through, but that does generally give us, aside from the slight optical illusion going on here, a pretty clean transition across that gapped region. So I think we can now simulate this to see how it looks. So let's run that. And this will take a short while to run through because there is quite a bit of operation there. However, as we can see, and I'm going to pan around to make this obvious, slow it down a little bit, it's basically treating this as if that surface contour remains uniform throughout, and it means that we don't have any weird jumping around up here and then transitioning over to here and then coming back for it. So we actually maintain complete uniformity of the surface finish as it goes. Obviously on a production part you may want to slightly chamfer or fillet this edge as well, just to really clean everything up, but for the sake of maintaining uniformity of surface finish with regards to toolpath marks, this is a really useful tool. So I'm going to speed this back up now so we can see what our final result looks like. And once we've got that, we can take a look at the verify compare result, which looks pretty good. There's a little bit of extra crust here, but nothing serious. Again, that can be managed with handling tool step over settings. I mainly haven't done anything about that because I want to give a fairly good illustration without it generating really lengthy simulations. So now that we've done this, I think we can probably take a look at multiplying this out so it covers both halves of the part. So at this point we're going to go back up to the surfacing folder, and we are going to add a multiply group there, which we will need to move the parts into, of course. And we are now going to set a round array with step of 180 and the base coordinate being the global coordinate system. We generate the toolpath, and that should give us a nice clean rotary illustration of what we've been working on. Perfect. So I'm generally very happy with that, although obviously I do want to make sure that we don't have any wild links or leads there. So I'm thinking we should probably generate a simulation of it. So let's do so. I'm going to run through the initial multiply group anyway because I want to see what the transition looks like. So let's do so. We'll leave it running nice and fast though, just so we get a clear idea. But for now, that's looking pretty positive. There's, there's no mad transitions or anything in there. Nothing unexpected is going on. So far, we've had no alerts, which is always good. And that is a nice clean transition with pretty much exactly what we were expecting from it, which is always nice to see. So once this is completed and we're satisfied that there aren't going to be any major errors to rectify, we can subsequently look at moving on to the final finishing process. So I shall see you in that video. Take care.